All right, so let's talk about the relationship between moles and volume, and let's also mix in grams. So exactly what you need to know is that the most important thing here is at standard temperature and pressure, you want to know that 1 mole is equivalent to 22.4 liters of particles. So 1 mole can literally be any sort of element or compound, right? But let's dive into some problems and really just figure this out. So let's say we had 10 grams of NH3, and this was obviously at standard temperature and pressure. I'm going to drag this down a little bit. All right, so how would you go about solving this? Well, the first thing you want to recognize is that you are starting with the grams, and you want to get this into liters, right? So I should probably write this into liters, question mark. All right, so how you go about solving this is by setting up a equivalent fraction. So let's just put 10 grams at the top, 1 at the bottom, just to represent it as a coefficient. And then you're going to bring this over, and you want to cancel out the grams, right? You want to convert the grams into moles. And so how you do that is the fraction at the bottom here is going to have a grams, because these two are going to cancel out. And we know we want to convert this to moles, so 1 mole is equivalent to what? Well, in our case, we're going to have NH3, right? So NH, let's bring this over. So we're going to have NH3, which is going to be nitrogen, which is 14, and then 3 hydrogens. So that's going to give us a gram formula mass of 17. Let's go back over here. So we're going to have 17 grams for 1 mole. All right, perfect. So now we have the mole amount. So from here to here, we went from grams to moles, right? But we still have to have this missing section here where we go from moles to the liters. So how you do that is we already know this relationship up here where 1 mole is equivalent to 22.4 liters. So if we set this up, we want to cancel moles, and so moles will go on the bottom. So 1 mole, and that's going to be equivalent to 22.4 liters. Now we can just multiply everything across and divide by everything on the bottom, and that'll give us 13.18 liters. That's our answer for that. All right, let's move on to a second problem for this example. And let's say we start with volume. We want to get grams at the end, so we're going to have to convert to moles and then finally grams. So how would we go about doing this? Well, it's very similar. So let's say we had 70 liters of O2 at standard temperature and pressure, and we want to get this to grams. So in the process, you're going to be converting this to moles either way. So we're going to set up our equivalent fraction, 70 liters over 1, and that's going to be equivalent to liters on the bottom because we want to get rid of the liters, right? So liters here. So we know we want to convert this to moles, volume to the moles to the grams. So 1 mole and then 22.4 liters on the bottom. And then in the other parentheses, because here we went from volume to moles, and now from here we want to go from moles to grams. And so moles on the bottom, we want to cancel the moles, so we're left with the grams. And so we know 1 mole, and then we have O2 here. O2's gram formula mass is just 16 times 2, so that's just going to be 32. Multiply everything across, divide by everything on the bottom, and you're going to get 100 grams as your final answer.